Ladies and gentlemen, it's time to cover precipitation reactions. Little science thing, this. Little science thing. Where was I? Oh yeah, precipitation reactions. Unfortunately, I can't explain them, as I did make this video before, but unfortunately all I did was take a picture. Now basically, I was able to get rare footage of a bird, namely a pigeon, Matt, doing a poo. Now, I realised that of course, when it's all being churned around inside the bird, in the pigeon, it's basically liquid, isn't it? But however, when the bird poo hits the ground, it will become a solid and a liquid. And that was my inspiration for a precipitation reaction. As essentially, precipitation reaction is when a liquid is turned into two precipitates. One is a liquid and the other is a solid. Now, in real life, precipitation is done by taking a liquid and placing it in a funnel with filter paper in the way. Then what happens is that this filter paper only lets the liquid through, which means that out the funnel comes the liquid precipitate, leaving the solid behind. And that separates, and that will be how a precipitate will be done. However, a little example would be that when precipitated in such a manner, the copper-2 ions form a jelly-like precipitate with a sodium hydroxide solution when they're precipitated. And that's precipitates. And now, it's time, ladies and gentlemen, to show you all about superconductors. Here is an example of a superconductor. A superconductor has multiple little bits sticking out, as shown by this grass. Yeah, and it has a lot of delocalized electrons, which mean that it can conduct electricity in a really good manner. Really useful, actually. Now, let's say that all of this grass is a superconductors, and that I, Delaney train, have actually become mag-leave train. Now, a mag-leave train creates a magnetic force in opposition to that force created by the superconductors, which means that if a mag-leave train goes on, it's actually floating and it's going really, really fast. It's going along on the superconductor perfectly, really well. It's great. It's fast. Look at me go. Look at me go. Jeez. And therefore, with the superconductor, it's really useful because it's not that expensive too. But however, a real problem is that it's quite cold out here, and that superconductors can only really work properly in really cold temperatures. So it's really hard to recreate that temperature. However, scientists are working on ways to make superconductors a lot easier to use by making them able to work at higher temperatures. Let's hope for all the trains like me that they succeed.